We are going to talk about chickens. That's exciting. I love chickens, but we're not actually going to talk about chickens as such. We are going to talk about building a chicken pen or a chook pen. We're going to build a chook pen up against an existing shed. And here's our chook pen. It's going to be like, it's going to have three sides because one of them is going to be the edge of the shed. So it's just got three sides. And the question you're asked is, you've got 20 meters worth of fencing material to build this chook pen, the surround of it, okay? So what's the maximum area your chook pen could be? And what would be the dimensions of that chook pen? So if we want to make it as big as we can, the area, what will be the dimensions of our chook pen? So I'm going to need to know this distance here, right? This longer side and this other side, okay? And of course, there'll be two of them because I've got three sides to make up my chook pen. Let's look at the maths. I don't know how long this side is. And in maths, when there's a number that we don't know or a value we don't know, we often use a pronumeral or a letter. So I'm going to say this is X. I don't know what this is going to be yet, but I know it's going to be something, so I'm going to call it X. All right, let's have a look at, well, obviously that means the other side is also X. It's the same. It's a rectangular. Now, I just realized in the question, I didn't say, hey, it has to be rectangular. I'm saying it now. It has to be rectangular. Sorry. So I've got X along here, so this must be the same. What on earth is this side here then? Okay, well, let's think about it. The yellow bit, which represents my edges, is 20 meters. Okay, so really I've got 20 minus 2 lots of X. So this side I could write it down as 20 minus 2X. All right. Can you start to feel the algebra coming on here? You should be able to, because the next thing I want to know is, if I want to know the area, how do I calculate the area of a rectangle? Hopefully you remember that the area of a rectangle, so the space inside my pen, to get the area of a rectangle, we multiply one side by the other side. So I'm going to multiply X by 20 minus 2X. I can see here that I've got some brackets and my algebra now should be kicking in, and I can see that I can expand those brackets. And when I do that, this is where the magic happens, folks. What have I got? I've got a quadratic equation. I've got something that has the power of x squared as its highest power. I've got a quadratic, and I know, and you know, that quadratics, when I graph them, they graph as parabolas, okay, a curve. Hopefully you remember, though, if the coefficient of x squared is a negative number, and it is, in this case it's -2, that my parabola is going to be upside down. So I'm pretty confident that a graph of the area of my chook pen is going to graph like this. And I know that if it graphs like this, the little bit at the top where it tops out is called the maximum. And guess what? That's what we're trying to find. Look at the question. We're looking for the maximum area. Man, can you start to see it coming together? I hope you can. Right, what's next? I'm going to draw up a table of values for my quadratic equation. I'm going to put in across the top row are my x values, and the bottom will be the area. Now my x values will be the independent variable. I can pick any values I want for x. I'm going to start at 0 and I'm going to go up to 9, and hopefully that'll give me something to work with. The a values will be dependent because they will depend on the x values that I substitute in. You've done this before, so hopefully this isn't new. I'm just going to take values from my x and I'm going to put them into, into my equation. So wherever I see the x in this case, I'm going to replace it with the 0. Put that in your calculator. I don't need to. I can see that that's going to be 0, that's going to be 0, so my area is going to be 0. Let's do the same now with the value 1. When x equals 1, I substitute that in and I get an area value of 18. Do the same now when x equals 2, I substitute that into my equation and I get an area value of 32. I'm not going to bore you with the rest. Let's just fill them all in. If I continue to do those substitutions, I'm going to get these values. Hang in there, we're almost done. I'm now going to graph, because remember, each of these represent a set of coordinates. So I can graph them. This will be the point 0, 0. This would be the point 118, 232, etc., etc. Now when I graph them, each of those points, it'll start to look like this. You excited? I am, because when I join them, I get a parabola. How does that help me find the maximum? Well, we're almost there. I could see, just probably by looking at my table before I even graphed it, I can see the numbers going up for my area, and then it kind of gets to a maximum value here, and then they start to come down again. So I could just look at that and give me my answer, but we wanted to show how that parabola, how everything sort of fits together. And when I graph it, I can see that the maximum is right at the top of my parabola here. If I drop a line down from that maximum point, this is my axis of symmetry for a parabola, I can see it hits the x value of 5, which lines up with what I had here when my area value maxed out at 50, the x value was 5. We're done. We're there, because I know now that the x value that we were looking for, our unknown when we started, is actually 5. So that line, or that edge of my pen, will be 5 meters. What does that make this one? Well, if I take that 5 and I substitute it into the 20 minus 2x, I get a value of 10. 5 meters by 10 meters. The pen should be 5 meters by 10 meters, and that will give us a maximum area of 50 square meters. If we made the pen something else, the area will be smaller. So just as an example, if I made my pen 2 meters by 2 meters on each side, that would leave me 16 meters of length. I'm only going to get an area of 32. So anything that's dimensions other than 5 by 10 is going to be less area. That is what we call using a quadratic model. So using quadratic equations to model a real world scenario to help find a solution to a problem. Well done.